Hello everyone. Today we are working on the 8-6 notes common logarithms. So everything we've done so far has been really nice. Like all the numbers work nicely, we can get the bases to match, everything just works nicely. But what happens when it doesn't? So let's say we have the problem 3 to the 2x plus 1. Well, when we have exponential problems, we usually try to get the base to match. But I cannot rewrite 3 to a power and get 12. So that's not going to work. So then maybe I say, okay, I'm going to rewrite it as a log. So then we rewrite it as a log, and that will give us log base 3 of 12 equals 2x plus 1. But again, log base 3 of 12, 3 to what power is 12? I don't know. We're kind of stuck, okay? So finding a common base doesn't work, and rewriting it as a log, does that help? Nope. So now we need another method. This new method is called the change of base formula. For all positive numbers a, b, and n, where a is not 1 and b is not 1, log base a of n is equal to log base b of n over log base b of a. What does that mean? So that means you get to pick the base you want. We are going to choose base 10. And the reason we're going to choose base 10 is because all calculators find the log button on your calculator. That is log base 10. So what are we going to do? For example, if we have log base 3 of 11, we are going to take log base 10 of 11 divided by log base 10 of 3. So our bases, these b's, are both 10, and we're choosing 10 because it's the common log and we have it on our calculator to make things easy for us. Okay, you could also choose both base 2 or both base 12. That doesn't matter, but we're going to choose 10 because everybody's calculator has that. Newer models, you can change the base, but not everyone can do that. All right, so if you have a newer calculator and you can change the base, then your job's going to be even easier. Now, when you do the change of base formula, notice we had log base 3 of 11. We're going to rewrite that as log base 10 of 11 over log base 10 of 3. Notice the 11 stays on the top. The subscript of the 3 will be in the bottom. Okay? All right, so let's try a couple. We have log base 3 of 20. 3 to what power is 20? I don't know. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. So since 20 falls between 9 and 27, we're expecting our answer to be between 2 and 3. So let's check. If we rewrite this, we're going to say log base 10 of 20 over log base 10 of 3. And that's going to get us, little calculator here, log of 20 divided by log of 3 equals 2.72683, blah, blah, blah. Okay, let's say when we round these, let's go ahead and round to the nearest hundredth. That's going to give us 2.73. Were we expecting something in the twos? We were. Would I expect it to be greater than 0.5? I would, because 20 is closer to the 27 than it is to the 9. All right, let's try the next one. So we'll rewrite this as log base 21 of log base 10 of 21 over log base 10 of 9. And when we do that on our calculator, we get 1.385. We're rounding it to the nearest hundredth, so that will be 1.39. And you can tell, like, 9 to the first is 9, 9 to the second is 81. So clearly 21 falls in there somewhere. I'd expect it to be less than 1.5 because 21 is closer to 9 than it is to 81. Solve the following. Okay, so now we've got some exponential problems. 6 to what power is 40? I don't know. 2 point something, right? Because 40 is kind of close to 36. But we can't really solve this because we cannot get the bases to match. So let's rewrite it as a log. So when we rewrite this as a log, we get log base 6 of the 40 is equal to the exponent, which is x. So we will rewrite this log base 10 of 40 divided by log base 10 of 6. And we get 2.058, so 2.06. Next one, 2.1 to the a plus 2 equals 8.25. Again, let's rewrite this as a log. Log base 2.1 of the 8.25 equals the exponent, which is a plus 2. So on the left, we will do log base 10 of 8.25, log base 10 of 2.1, and that's equal to a plus 2. So when we do the log piece, we're going to get some decimal there. And you can do that all at once. Be careful because your calculator automatically puts parentheses. This is 2.84 blah, blah, blah equals a plus 2. Subtract 2 from both sides, and we get a equals 0.84. I should have mentioned, when your calculator, when you type in the log button, it automatically puts a parenthesis. So you are going to need to close the parenthesis before you divide the next log, okay? You're going to need to make sure you close the parenthesis before you do the division for the next log. All right, last one. 3 to what power is 15? No, it's not 5. So rewrite that as a log. Log base 3 of 15 is equal to x. So that'll be log base 10 of 15 over log base 10 of 3. So when you do that on your calculator, again, close that parenthesis before you do the division, and you get x equals 2.464. So that's 2.46. Now remember, you can always check these answers. Take 3 to the 2.46. 3 to the 2.46 equals 14.918. Okay, well, that's not 15, but it's pretty close, right? Remember that we had rounded the 2.46 because it was blah, blah, blah. So we got pretty close to 15. They might not match exactly due to rounding. All right. Now, notice we wrote subscript of 10 a lot. Okay. That gets annoying over time. Log base 10 is what we call the common log. Log base 10 is called the common log because we use it so often. So what we do is we just stop writing the subscript of 10. So here we have log of 25. That really is saying log base 10 of 25. We're just, mathematicians and a little on the lazy side, so we're just not going to write the 25. So if I do log of 25 on my calculator, I get 1.397. For rounding it to the nearest hundredth, that will be 1.40. Log of 563 is 2.750, so 2.75. Let's try the next one. Here we have 2 to the 4x equals 32 to the x minus 1. We can do this one old school. We can rewrite 32 as 2 to the 5th, and that's raised to the x minus 1. So that gives us 2 to the 4x equals 2 to the, remember we have to distribute that, power to a power we multiply. That'll give us 5x minus 5. The bases match, therefore the exponents have to match. Go ahead and solve that. Subtract 4x from both sides, add the 5 to both sides, and we get 5 equals x, or x equals 5. All right, how about number 11? First thing we want to do is we want to move that 3 over. That gives us 5 to the x plus 2 equals 22. Now, this one I cannot get my bases to match, so I can't do it the old way. So I have to do it the new way of rewriting it as a log. Log base 5 of 22 equal to the exponent. Remember, log base 5 of 22 is just some number, okay? It's going to give you a decimal. So we rewrite that in our change of base formula. Log of 22 divided by log of 5 equals x plus 2. Find the log of 22. Don't forget to close your parentheses. Divide that by the log of 5, and we get 1.92 blah, blah, blah equals x plus 2. Subtract 2 from both sides. X equals negative 0.0794. If we're rounding that to the nearest hundredth, negative 0.08. Let's see, did I say a word around? I did not. So we'll round to the nearest hundredth. If you're not sure, plug it back in, check and see how it works out. You'll get something pretty close to 25. Number 12. Number 12, we look at those bases. We've got a 4 and an 8. We can rewrite those both with base 2. That's 2 to the second to the x minus 1 equals 2 to the third to the 1/2 x plus 2. Power to a power we distribute, 2x minus 2 equals power to a power we distribute, 3/2 x plus 6. Our bases match, therefore the exponents have to match. I'm going to subtract 3/2 x from both sides. That's 1/2. And then I'm going to add 2 to both sides. So what does that give us? That gives us 1/2 x equals 8. Multiply both sides by 2, and we get x equals 16. Number 13, not written perfectly in exponential form, so we need to get it there first. Add 7 to both sides. That gives us 3 to the x plus 5 equals 99. Now, do we have 3 to a power to get us 99? Nope. So we cannot write them in the same base, but we need to rewrite it as a log. Log base 3 of 99 equals x plus 5. All right, now what? Now log base 3 of 99 is just a number. Log of 99 divided by the log of 3 equals x plus 5. Log of 99 divided by the log of 3 is 4.18 blah, blah, blah equals x plus 5. Subtract 5 from both sides, and you get x equals negative 0.817. So that's negative 0.82. Real quick, let's try to set up these last two. We cannot rewrite this one as a log, so with common bases. So we're going to rewrite it as a log. Looks like this. Log of 110 divided by the log of 15 is equal to 1.73 blah, blah, blah equals x squared. We're going to take the square root of both sides. Don't forget, when you take the square root of both sides, you need your positive or negative. So when we do that, all calculator, don't round until the very end. We get x equals 1.32. Don't forget your positive or negative. Last one here, 16, we can rewrite as 4 squared to the x. This is 4 to the x plus 3 to the 1/2 power because it's the square root. So now we've got 4 to the 2x equals 4 to the 1/2 x plus 3/2. That was kind of messy. And you can go ahead and solve the rest of that. Okay, so when you get those bases to match, those exponents have to match. Work your magic, solve your equation, and you get x equals 1. And it works because I checked it already. All right, those are your notes for today. Have fun doing the homework. Bye.